This is part 4 of the Kyosho Ultima RT6 Stadium Truck Build series. So I have the steering servo installed and the front tower and the front body mount posts, and I've assembled part of the front suspension here. Okay, so let's start with the servo installation. I'm using a Turnigy Trackstar, what is it? The TS920 servo. It's a very fast servo and very reasonably priced. I was using it on my B44, but since I don't run that anymore, I put it in this. When you mount the servo, there's actually a few things to consider. First, make sure to not have any servo horns mounted. I kind of made that mistake. Because you have to measure out from the back side of these ears to the top of the servo horn mount, and depending on what that measurement is will tell you how many spacers you need between the servo and the servo mount in order to get the right steering geometry. Okay. Now, although they do give you all the parts here to build a servo saver, they also give you standard servo horns in the kit, just standard, solid servo horns. And it turns out that they're about almost exactly the same shape as the team associated servo horns that you would get on a B4 or a B5 or a B44. So those that part is very similar to the Kyosho part. So I have a couple of spare associated parts, so I just used that on this servo because I had already mounted it by the time I realized that Kyosho includes standard solid servo horns in their kit. And by the way, if you're interested in running these Turnigy servos, the type of horn you would use is the Futaba style servo horn with the number of teeth on the spline. So any of the horns that say F on it will mount onto these Turnigy servos. So this is simple. These side braces here, they say that you can take some of the screws out. May be removed by adjustment. So basically that means if you want to change the amount of chassis flex, this would be forward and backward chassis flex. You can remove some of the screws for these braces and allow the chassis to flex a little bit more, forward to backward. Right now I have all the screws in. Then you put the brace down. That's pretty straightforward. Put the tower in. That's pretty straightforward. And then you mount the front body posts. Now, a few things here. The front tower that came with the kit has 2 holes on the top of the tower. This part is actually discontinued. The updated front tower has 4 holes, so 2 extra holes on the outside. I do have a spare tower that has that, but for now I'm just going to use this stock tower with what on this is the outside hole. For the new tower would be just the second hole from the inside. The reason for putting the extra 2 holes on the top of the front tower for the new part is that if you run your shock on any of those outer holes, basically the shock angle is more of a stand-up angle. That should give you quicker steering response and softer suspension on jump landings or bumps, but you will lose a little bit of mid-corner steering. So it's, that's the setup option you have on that other tower. The thing with this body mount here, what happens is if you're looking straight down after mounting the body post, you can access these ball studs here to change roll center and camber gain if you want, but you would need an actual nut driver. If you have a box wrench like this guy, in order to access these ball studs, you'd have to take out this mount, which means taking out these 2 screws here. Not necessarily a problem, but eventually the part of the bulkhead where these screws screw into will get stripped out. So if you really want to play around with front suspension geometry adjustments, get an actual nut driver so you can just reach in there and screw or unscrew those without having to disassemble anything. Okay, and you can, the camera's got to refocus here, and you can see it's there's enough space for that, but only for a nut driver, not for a box wrench. So after that, we get to the front spindle carrier assembly and the caster block assembly. This assembly is kind of interesting, and I realized that this little spacer here, this number 116 spacer, is very similar to a spacer used in a previous part of the build on the steering rack, this 116 spacer. So I was actually wrong in part 2 when I said that this 116 spacer actually comes from parts bag 1, because in fact it comes from multiple parts trees. Parts bag 1 has this guy with your steering knuckles and these two number 116 spacers, which would be used over here for this part of the build, okay? And I was being dumb and just not looking around enough to see if this part is also on another tree, okay? And it turns out that it is. It's also on this tree here for the steering rack, the number 116 spacer. So in fact, the instruction manual is correct. So I stand corrected on that for the steering rack assembly. But I would point out that it is kind of confusing, if you will, that they have the same spacer types on different parts trees, right? So this 116 spacer is here and here. This 174 spacer is here and here, right? So you kind of, and oh, by the way, it's also here for the rear hub carrier. And the 175 spacer is here on the suspension arm part and here on this parts tree here. So you can actually get certain spacers from multiple parts trees. So, you know, that can be a little confusing, but now that I've gone through it and you know it as a result, just bear that in mind when you're going through the build. So anyway, you know, you put these two bearings in. There's no like a crush tube in here like you would see on a Team Associated rear hub carrier, or even, you know, like on the Kyosho rear hub carrier. I think they have a crush tube in there. On the front hub carrier, there's no crush tube. You just have this axle, and it slots through the bearings. You put this plastic spacer on, and then you put this piece on, and that's it's a plastic piece, okay, that holds the wheel. You can get aluminum pieces if you want, but plastic part, I suppose, is sufficient for now. And then that mounts on, and you slot this hinge pin here through this hole, okay, or this drive pin here through this hole. And then an O-ring comes over and covers that piece right here, okay? So hopefully the O-ring doesn't break or snap over time. As O-rings oxidize or get exposed to ambient and they dry out, they tend to get brittle and snap. But, you know, that replacement, I presume, is not too expensive. And then after that, you have to put in the spring assembly. So the way this spring goes together is this part of the spring goes under this sort of clip piece, if you want to call it that. And then you slot the whole thing in, and inside the, looking into this opening here, there's actually two flat spots, one here and one here. So you can align this little assembly to go straight in, okay? And once you put that in, you slot this little pin through and everything holds in place. I was a little concerned initially about this pin here not being captured by anything. It's not captured by an O-ring or a C-clip or anything. It just kind of sits there. And I thought that maybe it would fall out or something. But actually, as it slots through this plastic piece, it holds reasonably snugly. So, you know, you can take it out, but it's not going to fall out, like if you shake it or anything. You actually have to get a pin in there to push that pin out. And as the wheel mounts onto this, it's going to cover that anyway. So I can understand why they didn't capture this pin with anything. It's just not really necessary. So once it's all assembled, right, you have this sort of spring-like action here for the quick release. So that's kind of cool. So once you put that together, you get to putting together the caster block assembly here. Now the caster block does have inserts in the front similar to what you would see on, say, a B5, for example, and I think these inserts are for adjusting caster. I haven't quite looked closely enough at how the holes align from front to rear and how that changes for each of these parts, but this talks about degrees. I don't imagine it's for towing. It's probably for caster. So the stock block is plus 0 degrees, but then I don't know precisely what caster angle this results in. Does it result in a 25 degree caster angle? Possibly, because you're using, if I had to guess, I'd say that's the case, because up here you start with the standard settings to 25 degree kick up, okay, and then if you're adding 0 degrees caster, that means your caster would be 25 degrees. And then I can add 2 degrees or 4 degrees to that, so I can get to 27 or 29 degrees. Or if I flip this kick-up plate around and run a 30 degree kick-up, then I get to, what is it, 25, 27, 29, 30, 32, 34 degrees. So I can go from 25 degrees caster to 34 degrees caster over 2 regimes of kick-up on the arms. So, okay, that's kind of neat. And you use a different insert on the left side and the right side. So the left side uses the B insert, and the right side uses the A insert. So these are not symmetric. And when you mount them, you have to make sure that the hole for the insert points toward the inside of the chassis. Okay? Now I suppose if you wanted to, you can make it point towards the outside of the chassis, and that would just pull the whole assembly in a little bit and make the front narrower than the rear. That would probably give you more steering response, although I'm not sure if there's any really good reason to do it. Other things to note, you do have adjustable spindle carrier height through these 2 washers here, so I can take this out, put it on top, or take this out, put it on the bottom, whatever. The actual caster block itself has only 1 hole for mounting the ball stud, so any camber gain adjustments would have to be done on the actual front bulkhead here. Okay, you can't also do it with the caster block. Unlike something like, say, a B5 or an SC5 or something like that, you can adjust the ball stud position on both the caster block and the bulkhead. Okay, maybe they felt it wasn't necessary because most of the time, if you're going to play around with camber gain, at least as far as what I've done, I just do it on the bulkhead. So it doesn't really affect me. But that's something I guess I should point out as a small detail there. That's sort of where I am in the build. I mean, the next thing is just to mount this, onto the arms. That's nothing special there. And then after that, I do the turnbuckles, mount those, and then I get to the diff. And I start doing, I guess, the assembly for the rear of the chassis. So the turnbuckles are steel turnbuckles, they're not titanium. So for a kit that's this expensive, I've commented on this for the ZX6 and I believe the ZX5 as well. I'm not crazy about the fact that it comes with only steel turnbuckles, but if you're going to spend this much money on the kit, they should include titanium units. It's not the end of the world if you're running steel turnbuckles. They're just not, I don't think they're quite as strong as the titanium units, but they still work. If you don't drive like an idiot, you'll be fine. So, yeah, we'll see how much further I get until I make the next video, but in the meantime, thanks for watching.